so 7-1 angles. Part 1, we're going to have 2 parts today. So part 1 and part 2. Part 1 is identifying and talking about the names of angles. Okay, so pretty simple. You kind of talked to me about this already yesterday. Somebody said, well, I asked what you knew about angles, and you said, well, acute, obtuse, right? Remember those? Okay, so that's like this first part. We're going to talk about those kind of angles. Naming and identifying. All right, so what do you remember? Remember what an acute angle is? So what? Yeah, it's a little angle. Yep. All right, but 2 things first. I'm getting ahead of myself. I like talking about those because I have fun ways to remember them. Angle, 2 rays with a common endpoint. So yesterday, when you were measuring angles, you were actually measuring 2 rays. Okay, rays, and then this is the common endpoint. So the common endpoint means what they share. And the vertex is also known as that endpoint. That's another name for that vertex, that endpoint vertex. So that's what an angle looks like. Luckily, we talked about this yesterday, so it's not like a headlights look. So rays, there's 2 rays put together, and that makes an angle. Vertex is like where they meet. The endpoint where they meet. Are you ready? You need another second? So now we get to acute and right angles and all that good stuff. So, acute angle, less than 90 degrees. And you don't have to write what I have. You can say less than 90 if you want, if you already know what that means. So acute angles are really small. And then right angle is exactly 90 degrees. So basically like the corner of something. So I just got this morning in the mail. The corner of this would be like 90 degrees. Okay, it's a perfect edge. Somebody in the other class said to me yesterday, well, squares all have right angles in them, which is true. It's all like a perfect edge. Sometimes on your homework or on like a sheet, or if they're showing you some angles, they'll have this box in the corner. That box is a good indicator of telling you it's a right angle, so you don't even have to measure it. Sometimes they will have that, and sometimes they won't. Don't automatically assume all things like this on your paper are right angles, because would an 89-degree angle look exactly like a 90-degree angle? Really close. And a 91-degree angle would look exactly like 90. So don't automatically assume, but if it does have this box in the corner, you can say it's a 90-degree angle. Okay, so this is how I remember acute, and you've probably heard of this before. Babies are cute and they're small. So this is like an acute angle. You guys get it? Babies are cute and they're small. So small angles are called acute angles. One of my favorite things ever. I don't know who told me that once. I'm like, why did somebody tell me that in school? I would have totally remembered that. Anybody need this? Okay. My next favorite one is obtuse angle. And I also have another good way to remember this. So this is greater than 90 degrees. So bigger, and that straight angle is exactly 180. So straight line, exactly 180 degrees. If we would measure that and put it on your protractor, the line would go across the whole bottom. So here's my funny way of remembering obtuse angles. Obtuse reminds me of the word obese. Obese means big. So that's how I remember it. I wish somebody would have told me that in junior high. I loved it. So obtuse angle, it's like obese, big. Anybody have questions so far? No? Remember this from last year a little bit? So you did talk about this. Okay. My other class told me they didn't ever measure angles last year. Not really. So that was the first time you had in a long time, probably. Good, I like when we do fun things that are new. Okay, so naming angles. Okay, so here's the deal. When you have an angle, you're usually given like 3 points on an angle or 3 letters. Okay, these letters can be used to name an angle. So if I look at that, I can name this angle actually 3 different ways. But the first thing I have to have, if I'm going to use all 3 letters, that endpoint has to be in the middle. Do you see that? So like these are 3 different names that I can name this angle. I can name it EFG. I can name GFE. And I could also just name it angle F if I wanted to. So there's 3 ways that I could actually name this angle, but anytime you're going to use all 3, that endpoint has to be in the middle. We don't use this one a whole lot. We don't use just one a whole lot because a lot of times they're going to have a picture of angles and there's going to be a whole bunch of them together. So let's say I'm going to make another one here. And let's just do this as H. Okay? If I would say angle F could be like that whole thing. So a lot of times if I want to name an angle, I'm going to use all 3 letters. Let's say I just want to name this one, EFG, okay? And maybe you guys say, well, I'm just going to call it angle F. Well, how many angles could that be in here? It could be this one, it could be this one. So a lot of times you don't see this one too often, but you see the 3-letter ones, okay? So how would I name this one? How would I name this one right here? HFG, what else? GFH, right, perfect. I could name it angle F, but to me that's confusing because I could be talking about another angle in there, so be careful. So usually they'll always give you some letters or numbers or something that you can use to help name. But still need this yet? Good? Cadence. I would love that. Anyone do Merrick's too? We could even put it on one sheet, Cadence, and make a copy of it. I just want to carry one sheet around. Alright, I'm going to go to the next slide. Okay? Measuring angles, talked about that yesterday. We're not going to worry about that. Vertical angles. Okay, vertical angles. You might want to draw a picture of this. Okay, because sometimes we get confused about what vertical angles are. If you write down the definition, I'll explain. Vertical angles are just angles that are across from each other. Okay, do you see how these 2, I'll just call them 2 line segments, these 2 line segments, and we create an intersection. On the opposite sides of the intersection, those are called vertical angles. So 1 and 3 would be vertical, and 2 and 4 would be vertical. Another thing about vertical is they always have the same, what do you think I'm going to say? What do they always have the same? What did you say? Yes, they always have the same measure, always. So let's say I was going to measure this one, and then let's say I was going to measure this one. They're going to have the exact same degrees. So they're going to be exactly the same. So if I would say 1 is 32 degrees, what does it measure 3? 32 degrees. Could I use that to figure out what 2 and 4 are? I could. Because what do I know about a straight line? 180. So if I know this is 32, how could I figure out what this one is? Yep, 180 minus 32. Let's see. 8. 148. This would be 148. And then what other one is 148 in here? Yep. You guys understand that? Did you see how I found what 148 was? Because what do we always say a straight line is? 180. So if I know this is a straight line right in here, okay, I know this is 32, and then I can use that to figure out what that would be right there. Okay, so let's try another one quick. Oh, how did I get to the little one? How did I get to the little guy? Jeez. Come on. Oh, see, now I'm big. Crazy. All right, so let's say I know this is 50 degrees. What other one's 50 degrees? Yep. Then how could I figure 2 and 4? 20 minus 50 would be, and then, oh, this would be 130. Good job. Nice work. The vertical angles always have the same measure. If I would take my protractor and I would measure angle 1 and angle 3, they would be exactly the same. Any questions? So many people forget this. If you don't have this written down, make sure you get this written down in your notebook, okay? All vertical angles have the same measure. All vertical angles. Cadence. Yeah, you're right. You are exactly right. You are exactly right. Yeah, that's easy, isn't it? Nice work. Anybody else need this yet? Okay. We kind of talked about this already. Congruent. Let's not even write this down. Let's write this. Congruent. Does anybody know what the word congruent means? Oh, you're so close. Let's just even make it simpler than that. Congruent means the same. The same. So many people say to me, what does congruent mean? Or they read it in their math book and it's in a direction and they say, what does congruent mean? It just means the same. Okay, and we kind of talked about this already, so I'm not going to worry about it. Congruent means the same. All right, adjacent angles. Okay. This is kind of tricky. So adjacent angles. The angles share a common vertex. You're like, what does this even mean? A common side and do not overlap. So we know vertical angles are 1 and 3 and 2 and 4, but there's also other angles in here that we need to know about. Okay? So adjacent angles share an endpoint. Obviously, they're going to share that intersection. Okay? And they share a side. They share a side. So adjacent angles are basically right beside each other. That's the easy way to put it. Adjacent angles are right beside each other. So adjacent angles here would be 1 and 2, 3 and 4. What other ones? Oh, 2 and 3, I'm sorry. 3 and 4, and 1 and 2. And 1 and 2, 2 and 3, 3 and 4, and 1 and 4. Everything that's beside each other. They're all adjacent. And I have them on the side here too if you'd rather list them. So vertical angles are across from each other. Adjacent angles are beside each other. There's a lot today, I know. Short amount of time. Sorry. It's all right. Any questions on this? Cadence. Because they don't share a side. They don't share a side. So if I look at two, I'm going to erase my drawing here. Okay, so adjacent share a side. So like 1 and 2 are adjacent because they share this side. 2 and 3 are adjacent because they share this side. 1 and 3, here's 1, and here's 3. See how they don't share a side? They are not butted up next to each other. That's why. That's why. Good question. Good question. Okay, let's see here. Bisector. I'm going to skip this for a second. Okay, and this is part 2, finding a measure. You'll be able to do this. Finding a measure. Let's see. Finding a missing angle. Okay, so they're going to give us something, kind of like what we did vertical angles. Remember I said, okay, this is 50, now find the missing one? That's basically what this is. Finding missing angles. Okay, so this looks confusing, but it's not. Okay, this looks confusing, but it's not. Let's pretend this is angle 1, 2, 3, and 4. Okay, so our job is to find x and y. You might be looking at me like I'm crazy, but guess what? You already know how to do this because you already solved the equations, and that's what this is going to be. All right, so get it written down, copy it down, and then we'll solve it together here. Okay, so what do we know about vertical angles again? What do we know? Yep. Same measure. So this has to equal this, right? And this has to equal this. Well, set up an equation. If this equals this, guess what that looks like then? Right? They have to equal each other, correct? This side has to equal this side. Do you know how to solve an equation then? Do you remember? All right, how are you going to do it? This is not going to come out well, but we'll do our best here. I'm going to minus 10. Oh, it is going to come out well. Plus 10, plus 10. I get 3y equals 60. So what's y have to equal? Nice work. So I know y is 20. And if I put 20 in for here, 3 times 20 is 60 minus 10, guess what is? 50. All right, so then see if you can find x. Do you know how you're going to find x now? You're going to set them up equal to each other. Now find x. See why it's so important? We had to learn how to solve equations. It's going to show up like 300 more times in your life, even in geometry. But you didn't know there was so much to angles, did you? What'd you get? What's x? 64? Okay, so x is 64, and y was 20. That's it. That's not so hard. Okay, let's do another one then. Let's do another one. All right, so here's my angles. We'll call this angle 1 and angle 2. So angle 1 is 5x, and angle 2 is 115. Now, before you solve anything, just wait. Because are they vertical? They aren't across from each other. They're adjacent this time. But what do I know if this is my one and this is my other one? What do I know what they should be together? How much should they be together? They should be 180 together. So I know this plus this should be all together, what? 180. So 5x plus 115 equals 180. I gotta do this equation stuff again. Figure out what x is. Figure it out. Getting close. Anybody want to give me their answer? Jasmine? 13. So then they might say, okay, x is 13, but I want to know what 1 is. What is 1 then? 5 times 13, which should be 65. Yeah, it should be 65. So you got to be careful what they're asking you. They might ask you to find x, and then they might ask you, tell me what angle 1 actually is then. So then you need to take that x and put it in for whatever's missing here. Okay. It's kind of fun, really. But it's like a puzzle. All right, let's do this one. I think this is my last one. Okay, so what do we know about this? It's a right angle. Pretend there's a box in there. So it's a right angle. There's a box in there. And if they all together, what are they going to have to equal? Whoa, they're going to have to equal 90. Yeah, so it's going to be 3x plus 60 equals 90. And then you can solve. This is the easy one. You could even figure this one yourself. Like, oh, okay, that's 90. I'm going to take 90 minus 60 and then divide by 3. I think it's 10. That's 10. Okay, so if x is 10, what does angle 2 have to be? 30, right? Any questions so far? Another vocab word that I missed before is called bisector. You can just write that on your picture if you drew a picture. A bisector, it basically cuts an angle in half, or cuts an angle in two somehow. So what do you guys think? Not too bad? Okay. Let's look at your homework. What do I got? 1 through 12 and 19 through 24. Let's look at that quick.